My name is Izzy Rose and I'm a third year PhD student, and I'm looking into gene editing possibilities for cystic fibrosis. The main difference is that in gene editing, you're making a permanent change to somebody's genome. In comparison with gene therapy, you're using DNA to create a transient effect that will then be metabolized and passed out of people's systems. So you might get a change within the body, but it won't be permanent. So my PhD, I've decided to split it up into 3 sections, which is what people usually do for their PhD. They usually have 3 chapters. So my first chapter is based on base editing for certain CF variants, in particular the G542X variant, which is the second most common variant in Caucasian people. So chapter 2, we're essentially looking at when we do the gene editing, is it going to certain cell types in particular? So are we seeing an increase in function in specific cell types because the gene editing machinery has just targeted such cell types? And then alongside that, we're also looking at, should we then be targeting these cell types? So which cells have the most CFTR in them? So for instance, the ionocytes have a really large proportion of CFTR within them in comparison to, say, secretory cells or ciliated cells. And so should we be targeting ionocytes specifically to get the greatest increase in function possible? My third chapter is actually based on wound repair for CF, because we know that CFTR is implicated in wound repair speed. And so I'm just looking into, can we improve wound repair in different CF variants? The rationale to looking into which cell types we're actually editing and which cell types in particular are having the greatest functional change when we edit them is that with the transient gene therapies that are currently in clinic, we can still modify what the therapy is packaged in to target specific cell types. So when we're editing, if we do see that targeting specific cells such as ionocytes gives us a greater impact on function, then perhaps we can start looking into targeting these vectors to these specific cell types for in-clinic gene therapy. There's such a wide range of what you can do with science and experiments, and it's so interesting to try and take into account what everybody else has done before you and then put that into your own experiment and just see what happens at the end of that. So from the start of being in the SRC, the thing that I've definitely enjoyed the most is being able to talk to the other PhD students and get their input in the basic techniques that we all have to do. Also having access to the other supervisors and just being able to ask them really basic questions to make sure that I'm on the right track with where I'm going and making sure that what I do is actually worthwhile. Additionally, it's been the sharing of resources, definitely, because things like antibodies, they're really expensive. And so being able to just pop into the Francis Crick Institute and get an aliquot of an antibody is just really fantastic. Also, just being able to go on exchange visits to different labs and see how different groups work has been really great. So I actually got the opportunity to go to America, to Kansas City, and to be able to learn their techniques and then bring them back here with their knowledge has been really great. Doing a PhD, and especially being in my last 6 months now, I actually spend a lot of my hours here, but to relax in the evenings, most of the time I just am cuddling my cat and watching Netflix or spending time with my boyfriend.